just pretty much whatever you got, yeah. So let's look and see if y'all can send me any questions in, and we'll go from there. See if you got any homework done. Alright, here's one. Don't know if we've done it before. 1.2, number 23 online. Try that again. It's gonna be one of those days, people.
It is.
There we go.
Yeah, those are the video ones. You don't have to do those.
Well, we'll go ahead and do it anyway for the class.
All you gotta do is pop the video up, don't you?
I don't
Just write down
know.
the number.
No, it says correct order pair is f of -2 is equal to whatever you plug and shove. I don't know about the video. I don't know if you have to watch the video or not. I really don't know. So f of -2, the way that you did it way back in pre-algebra is you had your x and your y, and you plugged in -2, and -2 times -3 is what? 6, and 2 plus 6 is 8. So that's the way you did it back in pre-algebra. Now, you hold your pinky up, and you go f of -2 is equal to 8.
Wouldn't it be 4? Because 2
Wouldn't
minus
it be
6.
nice if, huh?
Wouldn't it be 4 because 2 minus 6?
Well, let's see, let's plug it in. 2 minus 3 times -2. What's -2
Oh.
times -3?
Never mind, I got it. It's our Monday, just.
There's your ordered pair, -2 and 8. See, you did it back in pre-algebra. The only difference now is you hold your pinky up and you go, f of -2 is equal to 8. And there's your answer.
I wonder why they need you to click on the video then.
I guess in case you needed an explanation. See if the speaker knob's a little bit in here. Yep, stole the knob.
F of 3. And what it means is that any given
Oh, it's just
expression,
teaching me
in
how to
this
do it.
case, is given to us as an equation of f of x equals.
All right. So that's good. That's 1.2. 22, is that the same? Is that the one that you said had the video on it? Let's look.
Yeah.
Okay, express the set of real numbers. X is greater than 2, greater than or equal to 2 in interval notation. Well, does anybody know what this is called? What kind of notation is this called?
Set builder?
Set builder. Or course, all my 102 students should have said that, but they didn't. Set builder notation, and they want it in interval notation. Best thing to do when you don't know is graph it. And what does this mean? Does this mean it's inclusive or exclusive? Inclusive. So that means you're going to put a closed circle on positive 2. And what numbers are greater than 2? Everything to the right. And this arrowhead right here is called what? Infinity. And this arrowhead is called negative infinity. So if we read from left to right, we're going from 2 to what? And that is your interval notation. And that's a good question because a lot of people have taken Algebra 1 and Algebra 2 and don't know the difference between the two. Huh? Which one is most used? A lot of algebra teachers, especially me, like that because we read from left to right, and that's the way you write it. Capiche? Feel good about yourself? Good. Okay, this is gonna get on my nerves. I have to go to the email every single time. No. 1.224. Okay. Now, let's go over. Okay, before we go over this homework problem, let's go through the parent graphs. And that means I want you to pull out a brand new sheet of paper and turn it sideways. And I want you to draw it. Here's your sheet of paper if I can find the dadgum. Here's your sheet of paper. And I want you to make it bigger than that. There's your sheet of paper. And I want you to take your handy dandy straight edge or your freehand, divide it in half, and then make 4 squares or rectangles, whatever you want to call it. This is called your parent graphs or family of graphs. If you had me for 102, you've already seen this probably. The first one is f of x equal to x to the first power. F of x is equal to x to the second power. F of x is equal to x to the third power. F of x is equal to x to the fourth power. F of x is equal to the square root of x or x to the 0.5 power. F of x is equal to the absolute value of x. F of x is equal to 1 over x. And f of x is equal to 1 over x squared. Now, if you had me for 102, we probably just did 4 or 5 of these. I added on a couple of more because you need to know what they look like. Now, what I want you to do right now is go ahead and fill out most of those if you can. What do they look like? Draw a cross in each one, a graph, and just sketch what you think they look like. So this one will look like this, like that. And then whatever you don't know, leave blank, because we'll fill it in. We're going to fill in all of them. know any of them, just meditate on. The first one, I'll go ahead and give you, we'll do it in blue. I don't know, it won't make any difference. Anything raised to the first power, anytime you have a function raised to the first power, what kind of a graph is it? Straight line. Linear. You might want to put linear function in that first square. Linear. That's got L-I-N-E, line, linear. All right, fill out the others. 102 students, you should be able to fill out several of them. Unless you just forgot everything I taught you.
Oh, we really didn't go over graphing much.
This ain't graphing, this is family of graphs, it's sketching. We covered a lot of sketching,
We did.
because we did complete and square. Y'all remember that?
We did sketch really.
Okay, we didn't do any of it. I didn't teach you
No.
what you should know.
We didn't do this graph kind of
I
thing.
thought we did. What does the x squared look like? Parabola. Parabola. Spelled parabola. So anytime you see a x squared function, you know it's going to look like a parabola. A cubic function is going to look like one side of a parabola, and the other side is going to be flip-flopped. There's one side of the parabola, but the other one is going to be flip-flopped. It's called a cubic function. Anytime you see a cube, it's going to have some kind of form like that. A quartic function, that's what x to the fourth, quartic, or x to the sixth, or x to the eighth, or x to the 10th, even. You're going to see the same parabolic shape, but the bottom is going to square out more as the exponent goes up. It's called a quartic function. Even though it's you're not going to set the sixth, you can still call it a quartic function because it's going to follow the same shape, except that the x to the sixth is going to be a little bit more square. You might want to add that. Take your highlighter and highlight right here. So that you can remember or put more squared on the quartic function. Your square root function is always going to look like a swoosh in the first quadrant as far as the basic model. Anytime you add or subtract to the square root of x, it's going to change the shift, which is going to change the quadrant.
Now is it always going to start from 0?
Yes, well, most of them, yes. Yes. Most of these are parent graphs. They're going to start from 0, or they're going to be around 0, because plus 0, all their vertical shifts are 0. And there's nothing added to it. And we're fixing to get into all of that after today. The absolute value function, just remember, absolute value, absolute vodka. What does value and vodka start with? A V. So all you alcoholics can remember that. That's a joke. Don't take it personally. I don't know if there's any alcoholics in here. V. Absolute value function always will look like a V. 1 over x will look like that, which I'm not really care too much about right now, but I want to go ahead and show it to you. And 1 over x squared looks like a volcano. Now these are your basic models. When you go buy a vehicle, let's say you go buy I'm not a car person, well, just forget car. Let's say you go buy a truck, and you go buy a Dodge 3500 SLT Limited. The SLT Limited will have all what on it? All the bells and what? Whistles. It's going to have the TVs in the dashboard and the TVs in the back seat and all this other crap. But what if you just buy a Dodge 3500? It might have air conditioning, it might have a radio in it. Alright, that's the basic model. These are the basic models. Everything you study from here on out is going to be a form of these basic models. Some of them are going to be wider, some of them are going to be thinner, some of them are going to be flipped over, some of them are going to be moved to the left and to the right, up, down, whatever. But these are the basic models. These are your 3500s. These are your F-150s with just air conditioning and what? A radiator. No power windows, no carpet, no nice seats, no anything. These are your basic models. Now, let's look at the question at hand. We know that the absolute value looks like a what? A V. But we also have power windows and power door locks on this one. We've got a negative in front, and we've got a positive 4 to the right. Now, I want you to turn to another page. I'm kind of consolidating 2 or 3 sections in one day, all right? Because a lot of you have seen this before. So I'm going to go to another page, and it's going to be a continuation of this. Mostly all of these functions are going to fall in this kind of form. What did you say, Ms. Sud?
I said our homework makes this so much more confusing.
Oh, well, no. Your homework don't make it confusing. I'm a fantastic teacher, and I make it much easier. That's what it is.
Well, you should do us homework then.
I'm kidding. Oh, no, I'm not. F of x is equal to A times x plus h, quantity squared, plus k. Now that's the parabolic general form. F of x is equal to A times x plus h to the third plus k. That's the cubic form. Of course, you can go on, and we're going to do all of them because there's a reason I want to do all of them. F of x is equal to A times x plus h to the fourth plus k. F of x, no more sneezing, is equal to A times x plus h to the 0.5 or 1/2, which is the square root. We're going to write it both, plus k. And I'll write A square root x plus h plus k. And I'm just going to do the absolute value next because I'm running out of room, and I think y'all see the point. I think y'all see it, the pattern. F of x is equal to A times absolute value of X plus H plus K. What was that? Did y'all just hear a ding? Quit trying to make me out to be crazy. Was that out here or was that in my ear? Huh?
I said no, and everybody was like, yeah.
Did you hear it? I say, I understand what y'all are doing. Yes, I'm losing my mind.
No, it's a proven fact once you get so, or once
It's
you.
old.
That is
You
old.
can hear, like,
Stuff like that.
Old.
No, they said once you get over 25, like,
I heard a
well, I
ding.
got a few years.
I heard somebody at your like 29 already. I heard something that sounded like a ding. It might have been in here. I don't know. Not in here. Here.
No, like.
Y'all are jumping a lake, all right? All right. Take your highlighters, and we're going to highlight in yellow all these guys.
All the A's.
Yep.
A plus.
Notice where the A is. The A is in front of the parentheses, just like it always has been. It's a coefficient. The A tells us orientation of the graph. So you need to write that down. I don't have a, hold on a minute. Let's see if I can get this. I hate this thing sometimes. It's a conspiracy. And we all know whose fault it is. Bush. Okay, y'all got those written down? Y'all are impressed, aren't you?
Oh.
All right. The A's are for orientation. Meaning, if it's wide, if it's skinny, if it's upside down, if it's right side up, well, what tells you what? Well, if A is negative, it's the opposite of the normal form, which I just showed you the normal forms. The parent graphs, I call them parent graphs. So if you have a negative A, that means that you take your parent graph and you do what? You flip it. So if it's negative, it's opposite. If it's positive, it's a parent graph. It looks like a parent graph. If A is between, I already told you on no coffee, 0 to 1, if it's a fraction, some of you people that have wrenches, you know, like, what's a wrench? Okay? What are they? 3/8, 7/16, ½ inch. What else? After ½ inch, there's 9/16. Then there's 11/16. Then there's 3/4. 5/8. Sorry. 5/8 after 9/16. Then 11/16. Then 3/4. Then 13/16. Then 7/8. Then 15/16. All of those are between 0 and what? 1. Now you need to make a note of that, because if I give you 3/2 as A, what is that?
1 1 1.
That's 1 1/2. So that's over A. That's over 1. I'm sorry. So you can't count just all fractions. You have to count the fractions between 0 and 1. And what I'd like to tell students is your wrench sizes. Okay? And if you don't know wrench sizes, think of cups.
Cups, that is right.
Half a cup, 3/4 of a cup, not D cup. 3/4 of a cup. I know some of y'all were thinking that. All right? 3/4 of a cup, half a cup, 1/8 of a cup, that type. Now, once you go to 3/2 of a cup, that's a 1.5 cups. That's over A, and that is another orientation. So, 0 to 1. It's going to make it wide. 0 to 1 will make it wide. So if it is a wrench size, or 1/217, or 1/566, then it's going to be very wide. What is a very applicable parabolic,
Sorry.
very applicable Anybody wanna take a guess? It's on the side of your house. Some of you get cable or a dish. That is a parabolic line.
I was like, siding? I don't know.
That's why you're gonna fail the class.
Sir, can I
Don't
just ask
say
you,
that.
how is a satellite dish, I just don't understand.
If you turn it flat,
Oh, yes, sir.
it looks like this. It's parabolic. It's like 1/516 x squared. It's, yeah, yeah,
See, this is why I'm gonna be a surgeon.
because you don't wanna deal with satellite dishes.
Exactly. There's no point. For me.
I can't think right now, hold on. Narrow.
The way that's written.
Narrow. As soon as I get $10, I'm gonna buy these calendars. I just don't carry cash. If you had a swiper on your phone, I could do it, cause I don't use cash, I use my debit card. That's why I'm always broke.
Okay, so what is the way that you have that written, what does it mean?
What?
A is greater than or equal to?
Give me a number greater than 1.
Okay.
Give me a
So-
number. 2. So if you have a 2 in front of this, then you know it's gonna be thinner. If you have 5, it's gonna be thinner than 2. If you have a 10, it's gonna be thinner than 5 and 2. And we're gonna do that here in just a minute.
It's like going twice as fast, or.
There you go, exponentially. All right? So that has to do with A. And that's the more complicated of them all, because you have to remember all of those, and some of those y'all just. So that's A. H and K are real simple. So make sure you make any note you need to about A's, because that's it. H is real simple. We'll highlight H green. Now I'll tell you this right now, I'm not writing these in general form 100%. And I do that for a reason. The actual general form is x minus h, quantity squared, whatever, plus k. But I do not write it like that, because if I give y'all a positive, y'all's brain will explode. So, what I do is I write it like this, and then I tell you, if h is positive, you move to the left. If h is negative, you move to the what? Right. This is the only time that you will see this opposite action. And the only reason that is because the general form is h minus k, quantity to the n power plus k. Now, what if I give you a -4? And I give you the general form of h minus k, and I give you h is equal to -4. Then it would be h plus 4, which would be a vertical or horizontal shift of left 4 places. That's why I don't show you that, because some of y'all will go, huh? So, if you've had another math teacher explain this to you before, and you didn't understand it, that's probably why. If you just remember that this is the only time in math that positive is left and negative is right, then you'll be okay. And that is your horizontal shift. Now, I'm going to let y'all think a little bit, because y'all are smart people. If H is the horizontal shift, what do you think K is? Oh, I can't get anything past y'all. Give y'all a biscuit, and y'all can solve the world's problems. All right? So K, and we'll highlight it, mauve.
You need to make this a daily routine,
What?
For real.
reading breakfast, cause then we're on top of stuff.
probably just buy y'all a car while I'm at it.
That would work too.
Yeah, I figured it would. LookingForSugarDaddy.com. Alright. K is gonna be pretty normal. Positive up, negative what? Down. So, K is gonna be equal to a positive. That means up. K equal to a negative. That means down. And that is your vertical shift. Okay, just stop writing in the middle of a, okay, that's fine, it's just gonna stop now. Now it's not gonna work. This is so freaking irritating. Okay, that's good. There. Listen, let's just be glad that it's writing. Okay. Now, I've just covered one of the sections in chapter 2. I don't know which one it is. But, and this is the way I teach this class. Now, I'm not doing anything different that I haven't done in the last 2 or 3 semesters. I always teach this first. Right? As soon as I get one of these questions, which you sent, I go into this because the rest of chapter 2 is all about this. And chapter 3 is completing the square. And we are going to drive completing the square in your brain until you're dreaming about it at night.
Literally.
Yep, because I did it in 102. And you were going to thank me when you're in first calculus or second calculus and I ask you to complete the square and you go, oh yeah. And half the class is going, huh? Is that like the quadratic formula? Negative b plus or minus square root. It is the most useless thing ever to be in math.
Okay.
Is
You
this
only
when
use the
you
quadratic
have a
formula
calculator?
when you have decimals in a quadratic equation. That's the only reason you use the quadratic formula. Unless you want to lean on the quadratic formula because you don't want to teach completing the square because it takes a little bit more effort.
Oh,
So
sums
tonight,
up all my school teachers.
we need to do 2.1 and 2.2.
Now, okay, I need to tell you one more thing that's very,
What?
very important.
I was just asking him a question.
Do y'all notice anything about the H and the K? Yeah, they have the same sign, that's true, yeah. That's good, but that's not what I'm asking for. You're a loser. I don't know who said that, but anyway. What do you notice? The H is always connected to the what? The X. Write that down somewhere on your sheet because you're gonna get confused on which one's the X and which one's the K. The K is always outside of the exponent. Look at here. Here's your exponents. Where are they? There. There's your exponent, 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 absolute value. The K is always on the outside of the function, the heart of the function. If the number is beside the X and within the function, the body of the function, then it is H, it's not K. And that's where students get confused the most. Okay, so now let's go to the problem at hand, and you tell me what it looks like. What is A? -1, good. So you know it's a regular. 1 tells you that it's regular. It is a regular 3500. It only has air conditioning and it has the radio. So the steepness does not change. But A is also what? Negative. So that means it's the opposite of your parent graph. So that annihilates A and C. Why does it annihilate A and C as choices?
Because the graph is flipped.
Because it's, oh, outside the body of the function, so that means it's a vertical shift of plus what? 4. So which one has a vertical shift of plus 4 and opening down? D is your answer. See how easy that is?
So with the 4, you go up 4 and then point down.
Yep. The opening down, it's not pointing down, it's actually pointing up. That's why you say open down. Open down reflects the negative, and the 4 reflects the vertical shift. And what does the absolute value tell you? It looks like a B.
And
And you feel
so
good about yourself.
with B, if it was negative 4, it would go over 4.
It would be x plus 4 inside the absolute values, and there would not be a 4 on the outside of the absolute values. This is negative absolute value of x plus 4 closed absolute value. That's what that is. This is absolute value of x closed absolute value minus 2 or something like that, minus 4. This, yeah.
So
This is absolute value of x minus 4 closed absolute value.
So it's K, it goes up the Y axis, and if it's inside the function, it goes
Left and right, but if it's positive, it goes left, negative, it goes right. Unless you want to remember the x minus h, and then you have to remember all the other stuff, and I don't teach that. And it's less confusing for students. What y'all talking about?
Me?
You need to share.
I'm talking about dresses.
Okay, well, don't share. That's what I thought. All right, let's go back to 110. Oh, you just sent one. Did you
Yeah.
just send that one?
Mm-hmm.
2.1, number 3, and I think it's probably what we're talking about now, but
It is.
okay? All right, first of all, what kind of function is this? 1 over x. Yeah, thank you. 1 over x. All right, so first of all, I'm just gonna go over to the side over here. I don't have a marker, somebody. There's some.
Especially it's gonna be out.
So here is 1 over x, right?
So I see.
So what is this one doing? It moves, it's moving, it's opposite, yes, because this one is over here and this one is over here, so you know it's what? Negative. So f of x is equal to negative, and I'm just gonna put, I'm building the equation. 1 over x, and I don't know about anything else, and I'm just gonna leave it like that right now. All right, so that takes care of the flip-flop. That takes care of the thing over here and over here. All right, but what does this mean? That negative 4. That means plus 4. Okay, that means plus 4. So, like that. But, you don't write a 1 over x function like that. You write it 1 over x plus 4.
Okay, why would it be plus 4?
I just told you that. Turn back to your notes. If it's positive, that means what? Goes to the left. If it's negative, it goes to the what? Right. You have to study that previous page. I mean, you have to memorize it. I know you can't memorize it right now, but that's where you need to look at that page. Does it have a vertical shift?
No.
So that would be plus 0. So your final answer to this is f of x is equal to negative 1 over x plus 4 plus 0. And of course, you don't need plus 0, but that is your function. Now, let's see what the question asks. Yes, sir.
So put it in the denominator, it's fine.
Yes, because that's where it goes. First of all, determine the largest open intervals of the domain over which this function is continuous. Now, I don't know how much I've talked about domain with y'all. I know I talked about it a lot with my 102 class. When is the domain effective?
There's a number in, K.
No, when is the domain effective? The domain is effective when you have a radical in the function and when you have a rational in the function. Is this a rational function? Yes. It's got a denominator. What cannot go in the denominator? Zero. So set the denominator equal to 0, and that is your domain. So x minus 4, or negative 4, can you use negative 4 in this function? No. But what else can you use? You can use all real numbers, but x cannot equal what? That is your domain. Why can you not use negative 4 or 4 or whatever? Yeah, 4. No, negative 4. Because that will give you a 0 in the denominator. So I don't know what they're asking you, but that's the answer. The function is not continuous over all real numbers. The domain over which is, the answer is all real numbers except negative 4, and I think that's what this is asking. Let's see what their answer is. Yep, that's the same thing. Negative infinity to negative 4, but do you include negative 4? No. That's the answer. You can write it this way as a union, or you can write it that way over there. Or all real numbers, you can use all real numbers except for negative 4.
So that's what that little.
Yeah, I don't use this.
Okay, I'm very confused.
You're very confused.
We're gonna have to.
Okay, well then I've done my job today. Don't worry, we're getting there. That question was in chapter 2. We're still in 1. We're going to build up. You'll be okay. Number 10, 1.2. Okay, we just did that one, did we not?
Yeah.
Yeah, we just did that one. This is 1.2, number 12. Is it a function?
No.
No, because it's a circle. The domain is negative 2 to what? Positive 2. I don't know if it's going to ask you anything else. It's probably going to ask you the range, which will be from 1 to 1, negative 1 to 1. The range is negative 1 to 1. Is the graph a function? No. Anytime you have a circle, an ellipse, or a hyperbola, it's not going to be a function because the vertical line test is not passed. Okay? (1.2), number 8. All right, graph that equation. There's 2 methods to graph this equation. I'm going to let y'all take a minute and graph it. Now, there's two ways to graph this equation. One, and I go over this in in 102. First method is the chart plot method, in which y'all remember this from pre-algebra. You draw a chart and you put an X up here and a Y right here. And I pick multiples of the what? Denominator. -12, -6, 0, 6, and 12. Because I don't want to have fractions. So what's -12 divided by -6? 2. What's -6 divided by -6? 0 times anything is 0. 6 divided by 6, that'd be -1. And 12 divided by -6 is what? And that's the method 1. And y'all, most of y'all remember that because that's the first method you learned. The other method is called method 3. I call it method 3, and it's find the slope and the y-intercept. What's the y-intercept? What's the vertical shift of this guy? 0. So we got a vertical shift. It starts at the origin. So our y-intercept is 0, 0. Our slope is negative, so that means it's going left to right. What? Down. And our vertical over our horizontal is 1/6. Now, some of y'all that have been programmed, y'all see that negative and you think it's supposed to go with the -1/6. No, it's not. The negative tells us what? The direction. It's going left to right down. So, however you want to graph it, you graph it. I'm going to go over here. And I'm going to plot my 0, 0. And my slope is left to right what? Down. So there's my slope. And all I got to do is go 1 vertical and what? 6 to the right. 1 vertical and 6 to the right there. And there's my line. Vertical over horizontal. And that should be it. It's a miracle. Those are the two methods to graph a linear or nonlinear. This one can be used for both. That's why I teach all my students to pick 5 numbers, because you can use that for linear and nonlinear. That's the only one that you can use for both. Okay? So hopefully that'll help you. Next question. Is that the same one? Number 8, number 2. All right, do that one. Write it down and do it. x is less than 5. So is 5 inclusive or exclusive?
Exclusive.
Exclusive, so that means parenthesis or an open circle. So what numbers are less than 5? To the left of 5 or to the right of 5? So C is our answer.
What's the difference in D and C again, though?
This is a bracket, this is a parenthesis.
Okay, cool.
Bracket goes with inclusive.
Yeah.
Parenthesis is exclusive. So this is your answer. And let's read it from left to right. What's this arrowhead called right here? Negative infinity. We read from left to right. So your interval notation would be negative infinity, parenthesis, to what? 5 parenthesis, which is that right there.
So on the one we did before that, that was similar to that when we had the negative infinity to -4 and then it had a cube between it.
Mm-hmm.
What does that mean?
That's another way of writing it. I don't use that. You could just say all real numbers except x is not equal to -4.
How do you type in all real numbers?
They usually have, well, on a test, you would just type in, they usually tell you to type in all real numbers or a big R. Or they'll say, or they'll have a point. And if you put all real numbers on the test and it marks it wrong, just show me and I'll, but make sure you put x is not equal to -4. 2.1, number 3. Oh, we did that one. 1.2, number 22. We did? Okay. Number 4. I don't remember doing this. Okay, write this one with set builder notation. Notice you have a bracket and a parenthesis. Bracket and parenthesis. That means a lot. So, 1 to 8. I always tell students, if you don't know, graph it. So I'm going to take my handy dandy straight line maker. There's my number line. 0, 8, -8, 1, -1, and 1. Negative infinity to positive infinity. I do not like writing with this mouse. You can see it's working now. I'm not throwing away my video just because the equipment's not working. What room are we in?
242.
Two 42.
No.
What?
Wait, it is? Oh, okay, never mind.
242. NAC 242. And stylus. Again, lighting with stylus. And 1, so that means a bracket or a closed circle goes at 1. Okay? And we're going to 8, but what kind of circle goes to 8? Hold on a minute, let me put this one's open, let's put that one right there. And then I'll put a closed circle, if I can do this.
Why don't you just do the big, black,
I wanted to use the
the
circle.
black circle,
Which where?
go
Yeah, I
right
can do
there.
that. Make a huge, thing.
She made it big.
Oh, well, there it is, right there. I'm not gonna fool with it, because it might stop writing again. There. Alright, so what numbers are represented? How do you write these numbers right there? Oops.
X is greater than equal
Yeah, you
to,
make it all fancy, you put a brace right here,
less
and
than.
a brace right here, and an X such that, and then you write X
Is greater
is
than or
between, yes, is greater than or equal to 1 and less than what? And that's how you write it. And I'm sorry, my mouse writing skills are not that good, but if anybody wants to volunteer to come up here and write with the mouse, you can do that. It's very complicated to write with a mouse. And there's that answer. Okay?
So why is the first one greater than or equal to and the second one's not?
Because of the bracket and the parentheses. Right here. Bracket tells you that it's a solid circle. This tells you it's a an open circle. This tells you that it's equal to. This tells you that it's not equal to. And I went over that in 102.
Okay.
And I also told people, whenever I teach that, I say, if you don't remember this rule, it's going to confuse you for every math you take. And you've got to remember that rule. And I wrote it, and it went like this. I had a big closed circle. I had a big closed circle like this, and a set of brackets, and then I had a dash, and then I had these two guys. And then I had this, and then I had these, and then I had these two guys. Oh, this is frustrating. And I said, and I will say, in every one of my classes, if you do not learn those rules right there, you're gonna have problems with the inequalities in every single class you take. You've got to remember those two rules. Okay? All right?
Got it.
Got it? You feel good about yourself?
Yes, you did.
Next one. Okay, now I done got myself confused. Let me get out of this. There. That. Leave that. This is review question 2/13. Oh, number 8. Online number 8. I think we did that one. We did that one last week. I think we did all of these, but I'll check. Okay, I don't think we've done this one. That's number 4. 2.1, number 4. All right, draw it. I'll make it bigger for you. Draw the graph. I want you to tell me the domain and range of the graph. So that's what it's gonna ask you. They're also gonna ask you for increasing and decreasing values, and we'll talk about that on this. That's what's so frustrating. The Promethean works because the Promethean, whenever I touch it, that goes on. So that means the Promethean works.
Well, put it, you gotta touch the little thing,
There's nothing working.
no, 'cause it's on the mouse thing,
Huh?
it's on the mouse thing, the little pointer clicker thing.
I know, but it's still, see, it don't work. And that's what I've been having problems with all semester and last semester.
Try to calibrate it.
Huh?
Calibrate it.
It won't, I know it won't, I've already tried that. This does not work. It cuts this off, I don't know why. And they, and IT can't do anything about it, cause they don't know what's wrong with it. So now I gotta.
Can't you push the little button on the side of it?
Doesn't work. This is as good as a piece of chalk. It doesn't do anything.
Does it take battery?
Mm-mm. There's nothing mechanical about it. It's just a stylus, just like you use on your PDA or your phone or whatever. It's just a piece of fiberglass or whatever they use.
Is it like your credit card that it gets demagnetized?
I don't know, but it does it in different rooms. It doesn't do it in the same room all the time.
Is there another pin up there?
Hmm?
Is there another pin up there?
It's not the pen, it's the program, it's disabling me being able to write with this.
Have you ever corrected it by restart?
If I restart it, I lose my video, and that's why I'm not stopping. So, alright, so the domain, negative infinity to what? Positive infinity because of what?
It goes on forever.
The arrows, it goes on and on and on. So, domain is negative infinity to positive infinity due to the arrows. Range is from negative infinity to what? 5. And it's inclusive of 5, so that would be a bracket. And infinity, of course, would be what? Parenthesis, and that's what would be up here also. And I can't go back up there, so I'm not even gonna try it. Now it won't work. Really? There. Now, increasing and decreasing values. Increasing and decreasing values are only in respect only in respect to x. Now I like to tell students, think of think of flying a plane when you're talking about increasing and decreasing values. Okay? When you're flying a plane, there's two dimensions. Actually, there's three, but we're going to talk about the two dimensions. And what's the two dimensions? If you travel from here to Atlanta, what's that dimension? Distance. So, this way. But what else do you have with a plane? You have height, or altitude, or whatever. So, I'm going to take my handy dandy plane, and I'm going to put it down here. Okay? There's my plane.
Start doing the little.
Shut up. Do not laugh at my plane. I know it looks like a shark. Leave it alone. Alright. Now this plane,
Now you gotta do the buzzing sound.
alright, it's going in the X direction. Does everybody understand that? Alright? But what is it doing as it goes from negative, or negative 1, we'll say negative 1, to positive 2? What's it doing? It's going up. That's increasing. So your Y is increasing as the X goes from left to right. As the X goes from left to right, as you travel 2 or 3 miles this way, how far are you traveling? You're traveling a good ways up. You're gaining altitude. Is everybody with me? As I go, and I'm saying 2 miles. 1, 2, 3, 4. I'm just going to say 4 miles. As I travel 4 miles horizontally, I travel umpteen miles vertically. But we only care about the X because we know increasing is going what? Up. So we don't care about the Y. The Y tells us increasing or decreasing. So, from negative infinity to 2, what are we doing? From negative infinity to 2, what's happening? X-wise. From negative infinity, let's say, in respect to X, from negative infinity to 2, plane is what? Increase. Good. Somebody finally said it. Okay? In respect to X, from 2 to 4, plane is what? Huh? I didn't hear you. It's staying the same. It's level. No change, level, constant, whatever you want to call it. Is level, constant, no change. From 4 to infinity, plane is what? And that's how you do increasing and decreasing values. So, from negative infinity, as we go to 2, mile marker 2 in the highway, up in the heavens, up in the sky. As we go in to 2, we're gradually leveling off. Leveling off. And then from 4 to infinity, we are making our approach.
Please buckle your seatbelt. You are now landing. Welcome to the Atlanta airport.
Our two flight attendants, can't say stewardess, that's an insult. Flight attendants are freaking fracked up here. Now, that's how you do domain, range, increasing and decreasing.
Thank you, fine.
Okay?
American Airlines. Math 110.
Freaking fracked. All right. So, over what interval, blah, 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 is it increasing? Negative infinity
To 2.
to 2. And I know I don't have my brackets, but I don't care. We're just answering the question. You need to put your brackets, because there, see, or parentheses. Over, when is it decreasing? From 4 to infinity, and I'm just gonna put 3.
2 would be included, like a closed bracket.
Huh?
It would be a closed bracket, the 2.
Yeah, there's a bunch of people that fusses that say that it's not, and then there's some teachers that say that it is. I'll take either answer.
Okay.
But why on their answer do they not put bracket?
I think it's a mistake because what they're saying is, well, let me ask you this. When Michael Jordan jumps from the top of the key to dunk, he's doing a parabolic function, and at one point in time, he's actually what?
Leveled off.
Flying.
Fine.
He is. He's neither going up or what? Down. And that's the type of reasoning behind their parenthesis. It's technically, they're saying that that moment doesn't exist,
Right.
but it does. And that's why I'll take either answer. All right, what is this constant from? Now this is probably where they'll put the, say they don't even put the brackets here either. Okay, they don't put it in there either, so I'm not gonna worry about it. What's the domain of the function? Positive infinity. And what's the range? Negative infinity to 5 or whatever. I know it's time to go, just chill out. Y'all be okay. I gotta see where we're leaving off. Alright, so I need to delete all of these.
So for homework, we need to start doing 2.1 and 2.2.
Hold on a minute. You're asking me 2 things. I'm a guy. You can't do that.
I asked you like 30 minutes ago, and you still didn't answer me.
Well, that's why. You asked me why I'm doing something.
You were
All
just
right.
sitting there.
Alright, so that means we got these to go over. Now, let me get the roll right quick, and then I'll answer questions after I get the roll, because I need to get the roll, because I don't want to mess up and not get the roll, because that way everybody, the bureaucrats will go crazy down in student records.
Got sunburnt yesterday, so my whole back is Our first competition is in 17 days.
Where you
Wow.
confused?
I know, we compete at easily, and yesterday we just started
Y'all
throwing
will
full
lose.
outs.
Y'all gonna lose.
I didn't say we competed against